Okay, this problem gives us a particular circuit with 3 resistors in parallel, and it asks us to find the equivalent resistance of the circuit, the currents through each one of these resistors, and the power dissipated through each one of these resistors. Okay, so first let's find the equivalent resistor. So if I redraw the circuit, so there's just one resistor, I can combine these 3 into that one. These 3 are in series, remember, so the current coming through here splits up, and you have different current through each branches of that parallel circuit. So that's what we mean by this being in parallel. So the equivalent resistance then is just 1 over R1 plus 1 over R2 plus 1 over R3, and the reciprocal of all of that. We use the reciprocal addition rule. So I can also call that R1, 2, 3. I do that sometimes. So that's 1 over 3.00 ohms plus 1 over 6.00 ohms plus 1 over 9.00 ohms. I mean, if we wanted to add the fractions, we could put all these over 18, so that would be 6 over 18 ohms. Not really paying attention to significant figures here. Plus 3 over 18 ohms plus 2 over 18 ohms. So that's 6, 7, 8, 9, 10, 11 over 18. That's nothing nice. That comes out to 1.64 ohms. So now the question asks us to find the current through each one of these resistors. Well, we know that we could find the current using this equivalent resistance, but that would just be the current through the whole circuit. When the current comes into that junction, it's going to split. It's going to be I1, I2, and I3. And if we say I naught or whatever, I1, 2, 3, let's do that. If that's the current through the whole circuit, then that's going to be the addition of I1 plus I2 plus I3. So we need to find these values. But we only have the equivalent resistance. So how do we go about that? Well, if we found the voltage drop across this, couldn't we do that? So the voltage across, so if this voltage here is 18 volts, then that means as we go around the circuit, there must be a drop of 18 volts across this equivalent resistor, because, and it just makes sense, because if this is adding 18 volts of potential difference, we must be subtracting the full 18 here. If we weren't subtracting the full, if we were subtracting, say, 16 volts, well, then the next time you go around the circuit, you're going to get 18 volts plus the residual 2 from before, and on and on and on as you keep going around the circuit. So it would be a perpetual motion thing, or it would just, you could take one battery in Power City, right? As long as you go around the loop enough times, every time you're adding potential energy to these electrons. So that would violate conservation of energy. Can't do that. So if there's 18 volts here, we must subtract 18 volts there. So the voltage across 1, 2, 3 equals 18 volts. But that also equals the voltage drop across 1, 2, and 3, each one of these resistors. The voltage drop is the same in every branch in a parallel circuit. Again, that has to be true, because if the voltage drop here was 18 volts and the voltage drop here was 16 volts, well, you're going to have more potential energy per electron over here. It's going to flow around in a circle. That doesn't work that way. The voltage drop across everything from here to here is 18 volts, so that means in each branch of the circuit is 18 volts. So then, in order to find the current through R1, well, current is just V over R, so that's V1 over R1. Well, we know that's just V1, 2, 3 over R1, because all the voltages are the same. So that's 18 volts over, 3, which is about 6 amps. We repeat the process, and resistor 2, same voltage again. So that's 18 volts divided by 6 ohms, or 3 amps. And in the third one, V123 again over R3, which is 18 volts over 9 ohms, or 2 amps. So now the next question says, what is the power dissipated in each one of these resistors? Well, power, we can write it several different ways. So power can be represented several different ways. I always remember I squared R. We now have the currents and we have the resistances. Or you could say plug in for I, and you could have IV, power equals IV, or you could have power equals V squared over R, any of these things. Let's just use I squared R. So we're looking through power through the first resistor. It's I1 times R1. So that is 6 amps squared times 3 ohms. So that would be what, 36 times 3, that's 90, 108. Oh, excuse me, not amps. This is in units of watts, because this is power. And if you do the same with the others, you get 54 watts, 36 watts. Okay, so now what is the power through the entire circuit? Well, I can say the power 123 equals I123 squared over R123. We have the total resistance, R123. We don't have I yet. However, I could say I123 equals V123 over R123, right? Put that in. And let's see, I'm going to have V squared over R. So it equals 18 volts squared over 1.64 ohms, which is what we found up here. And the power dissipated by the whole circuit thus is 198